Hey guys, so I'm just making this video to go over this practice test with you guys. I won't go over every single problem, but I'm going to go over a lot of them because I know it's been a while since we did this stuff. So to do this practice test, there's a couple things you're going to need. Number one, you will need a periodic table. That's very important. Number two, you will need a calculator. And when you're taking this in class, you're going to have to use one of my calculators. So, like, the more practice you can get on a real calculator, the better. And then you'll also probably want to use this little diagram that we wrote in the very first page of the notes that has how to get from grams to moles to molecules, right? So these first questions, though, are just asking you to find the molar mass. So for these questions, you don't even need to do a conversion factor problem. You just need to add up the numbers on the periodic table to get the molar mass. So for example, MgS, to find the molar mass of that, you just need to add up the molar mass of magnesium, which is 24.31, and the molar mass of sulfur, which is 32.07, to get, let's see, 24.31 plus 32.07 to get 56.38. And remember, the units are very important with molar mass, so it needs to be grams of MgS over 1 mole of MgS. Okay, you're not going to get full points unless you put the units on there, so make sure you do that. Also, different periodic tables will round these numbers slightly differently. So if you have 24.30 instead of 31, like, that's okay. Don't worry too much about it. You can look up mercury on the periodic table on your own. Hg is mercury. That's pretty easy. Let's do this one with the parentheses so you can see how parentheses work. So this little 3, it's a subscript. That 3 outside the parentheses is going to distribute to both the hydrogen and the oxygen. So that means there's going to be 3 hydrogens and 3 oxygens. So what we're going to have to do is add up iron. So iron is 55.85 plus 3 oxygens. Oxygen is 16 plus 3 hydrogens, which is 1.01. Okay, and the best way to do this to make sure you get the right answer is to kind of multiply these separately. So 3 times 16 is 48. And 3 times 1.01, that's 3.03. So then I would add up those 3 numbers. So 55, oh, there's glare there. 55.85 plus 48 plus 3.03 gives you 106.88. And then again, just remember to do the units. So grams of FeOH3 over 1 mole of FeOH3. All right, now, and also, if you want to look this up in your notes, this stuff was in section 1.4. So if you want to review all the notes and practices we did with this, we did a lot. You can look, page 19. So these next problems are conversion factor problems. So this first one says how many molecules are in 0.65 moles of ammonia. So if you use this chart, we're starting with 0.65 moles. So we're starting here. The problem is asking me for molecules. So I'm trying to get to here. So I'm just trying to get from moles to molecules. That means I just need one conversion factor. And it's going to be this Avogadro's number, the number of molecules in 1 mole. So to set this up, I'm just going to go 0.65 moles. And technically I should write ammonia after. I'm just going to abbreviate that. And then on the bottom, I'm going to want to put 1 mole. And on the top, I will put Avogadro's number, 6.02 times 10 to the 23rd molecules of ammonia. and then my moles of ammonia will cross out, and I'll just end up in molecules. Now to put this on my calculator, I'm going to type 0.65 times 6.02 second E, because that means times 10 to the 23. Now it's not times E, it's just 6.02 E 23. You should get 3.913 times 10 to the 23rd. Don't forget that, times 10 to the 23rd. And that's going to be molecules of ammonia. All right. So next problem, how many moles are in 4.5 grams of BaCl2? That's not an I. Remember, when you have a C, C and I aren't usually together. It's an L, so it's chlorine. But we're starting with 4.5 grams. So we're starting at grams. We're just trying to get to moles. So this is just a one-step conversion factor again. And we're going to be using the molar mass. So we're going to start with 4.5 grams of BaCl2. Oops, didn't leave enough room for that. And now I'm going to need to have my grams of BaCl2 on the bottom and 1 mole of BaCl2 on the top. Remember, molar mass, it's always some number of grams per 1 mole. So that's how I know that it's 1 mole on the top. So I need to figure out the molar mass of BaCl2. So I'm going to do that down here. Barium is 137.33. There's 2 chlorines, and chlorine is 35.45. So we're going to go 35.45 times 2 plus 137.33. So 208.23. All right. So that's grams of BaCl2 over 1 mole BaCl2 for the molar mass. So my grams of BaCl2 cross out. If I multiply across the top, I'm going to end up with 4.5 moles of BaCl2 all over just a number, 208.23. So then I need to divide those. And I'm going to get a really small number. It's 0.022. I can round that. Oh, moles, not grams. Moles of BaCl2. So basically what that means is 4.5 grams is just a small fraction of a mole. 4.5 grams isn't very much. Okay, last conversion factor problem. So this one says, how many grams are in 9.3 times 10 to the 23rd molecules of CO2? So we're starting in molecules, we're trying to get to grams. So we're going to need 2 conversion factors for this one. So 9.3 times 10 to the 23rd molecules of CO2. I want to cross out molecules, so that means I want my 6.02 times 10 to the 23rd molecules to be on the bottom. And that's the number of molecules in 1 mole of CO2. I know it's a pain to write out all the units, but it's very important that you actually do that. Now, my last conversion factor is going to need to be the molar mass from the periodic table. So just down here, I'm going to figure out the molar mass of CO2. So carbon is 12.01. And then there's 2 oxygens. So if I add that up, 2 times 16 is 32, plus 12.01 is 44.01. So it's going to be 44.01 grams of CO2 over 1 mole of CO2. So my moles cross out, my molecules cross out, And then I just need to multiply across the top. So I'll do 9.3 times 10 to the 23rd times by 44.01. And I need to divide that by 6.02 E23. And I'm going to get 67.99 grams of CO2. So that many molecules of CO2 will weigh that much. Okay, so switching gears now, you're going to have a couple of electron configuration problems on this test. So to write the unabbreviated electron configuration for nitrogen, I'm going to use this colored periodic table. Here's nitrogen. So remember, this section over here is the S block. This is the D block right here. And this is the P block. And then down here we have the F block. So basically we have to account for all of the electrons in nitrogen. So the first two electrons are going to go in a 1s orbital. So we just kind of like count all of the boxes up to nitrogen is what we do. So it's going to be 1s2 to start with. And again, that's like the first and second electrons. The next two electrons are going to be in a 2s2 orbital. And then the last three electrons up to nitrogen are going to be in a 2p orbital, so 2p3. All right, now this one says write the abbreviated or noble gas electron configuration for rhodium. So rhodium is right here, it's number 45. So if we were to do the unabbreviated configuration, we'd be going all the way from the beginning all the way up to rhodium. But that takes a really long time. So instead of doing that, we're going to look at the noble gas before rhodium, which is krypton. And we're going to write krypton in brackets. And that basically is saying the electron configuration of krypton, like that's what that means in brackets. This stands for the entire electron configuration of krypton. So we don't need to write all of those orbitals because that would take a really long time. So we just write the stuff after krypton, which is going to be starting at 5s2. So krypton 5s2. And then going all the way over 1, 2, 3, 4, 5, 6, 7. So 4d7. So remember it's 5s, but on that same row it's 4d. All right, so that's how you do almost all of the problems on the test. For sure, email me if you have any questions, if you need more help. I went over this pretty quickly, so if you need more help, that's totally fine. That's very normal. So hope you guys are having a good day. We'll see you later.